All right, this is APAB Calculus. We're doing midterm review, and this is multiple choice number 2, which is a non-calculator question. So let f of x be the function above, which is piecewise. Which of the following statements are true about f? Okay, so the limit as x approaches 3 of f of x exists. Well, this would be true if the left-sided limit, right? And this is multiple choice, so to be fair, you really don't have to do as much of the actual work if it's just multiple choice, but the left-sided limit would have to equal the right-sided limit, right? That's what this would mean. So the way I find the left-sided limit is by plugging into the values to the left, right? And so this is a 3 plus 2, which would be a 5, right? And the right side would be a 12 minus 7, which is also a 5. So yay, that's true. So the limit does exist. Now, for f being continuous, right, the only thing that would make it, that makes number 2 different than number 1 is because this equal to means that the actual value of f of 3 is the same as that double-sided limit, right? And it turns out that that's true. We already know the double-sided limit is 5, and if I actually plug in 3, I get 3 plus 2, which is in fact also 5. So yes to continuity. The last question is whether this function is differentiable. So when we differentiate a piecewise function, we basically just differentiate the pieces. So what's going to happen is I differentiate x plus 2 and just get a 1 for x values less than 3. I'm intentionally not putting the equal to, and I differentiate the second rule, which would just give me a 4 for x values greater than 3. The reason I didn't put the equal to is because we actually don't know if f prime of x exists at 3. That's the whole point. And in this case, it doesn't, because the left-sided limit of the derivative, so in this case, it's false. And if you were doing this on a free response, the work that you would have to show would be that f prime, which is a 1, does not equal the limit from the right side of f prime, which is in fact a 4. And they're not the same, so it is not differentiable, and our answer is D. Right? Now, if this is multiple choice, you don't have to show as much detailed work. You don't necessarily need to show the correct limit notations, but if this were a free response, you would have to show the correct limit notations. And that's it.